Thank you all for joining us here today. Today's session is Ease Cloud Migration with Red Hat OpenShift Service on AWS. If you have any questions during this session, please put them into the question box and they will be addressed as we go on. And then just so everyone knows, today's session will be recorded and will be available on demand in about 5 days. Sometimes it's earlier, but we will make sure to send that out via email as well. Our speaker today is Matthew Brothers. He is a Senior Solutions Architect at Proficient. And Matt, I will kick it over to you.
Yeah, thank you, Caitlin. So we're going to talk a little bit about ROSA, which is the managed OpenShift service on AWS. And launching a ROSA cluster is actually going to be, we're going to skip over that because we're a little bit short on time. But so it's actually very easy. We'll go over that real quick, and we'll jump into how to migrate the application to ROSA and get into the demo. Next slide. So yeah, quick words about Proficient. We're a global organization, really focused on delivery. We have teams all over the world. We do nearshore and offshore. We're traded on the NASDAQ. And I think the most important fact is, the 90% repeat business because of the quality of our work. When we get into engagement with organizations, and so the reason for that is because of our our professionalism, and what I'm going to show you, kind of those practice of learning and capitalizing on what we learn, and really creating this repeatable, high quality kind of patterns. Next. So word on ROSA, if you're not already familiar, and even we can start with OpenShift, right? As you're probably heard, about everybody moving to container right now, and in particular to Kubernetes for container orchestration. OpenShift is really came out of the kind of de facto enterprise Kubernetes solution for container orchestration. That's a product from Red Hat that is based on the community Kubernetes, but then Red Hat adding their high quality security features and knowledge of server management, etc., to really make it something that is production ready and can be used in even a highly regulated environment. Security is very important, and quality. And OpenShift has been available on AWS for a while now. They've been partnered with AWS for a long time. They had an installer for AWS. This is pretty much the beginning of OpenShift as containers, and but you still had to manage your servers. You still had to manage your OpenShift cluster. It can get a little bit complicated depending on your environments and your knowledge of the platform itself. And so a few months ago, AWS and Red Hat partnered to come out with ROSA, which is a managed OpenShift solution on AWS. And so it really manages all the infrastructure aspect of your OpenShift cluster, from scaling your nodes, your management of your master nodes, what's called the control plane. And so really you only have to focus on the deploying your services on there, and there's a shared support model between Red Hat and AWS, so that you can have you can sleep at night and that your infrastructure is taken care of. And of course, it's AWS cloud-based, pricing, and so it's based on your actual consumption, which allows you to really control your cost and grow at your own pace. All right, so let's get to, I think we can get into the demo right away. So really, we're starting with a pre-existing ROSA cluster out of the box. What you get from when you use the CLI, when you're just starting with ROSA and you create your AWS account, there's a ROSA command line that you run, and it will ask you a few questions: how to deploy the cluster, if you want to, high availability cluster, or if it's just for development, or both, and then how many nodes you want at the beginning, et cetera, some security questions. It's very, very straightforward, and gives you access to the OpenShift console when you're done, and then you can start play around with it within a few minutes. Pretty much, it's really, really quick. So out of the box, right? We have to install a few dependencies using the very useful Operator Hub, which is kind of an app catalog for OpenShift. And while this is happening, and you can kind of look at what's being installed as dependencies, I want to give you a little bit of background about the accelerator. First of all, OpenShift already comes with a lot of tools to get you productive quickly. Tools that have been created by Red Hat and integrated into the platform, so they work really well together. That being said, it's still a platform, and so it needs to cater to a variety of use case and organization constraints. So it's very flexible, but it can also be a little bit overwhelming. What we learn, though, after years of delivery experience, is that there are a number of things that are common between projects to ensure success and agility, and leveraging the platform to the best of its ability. And so we figured out which tools to focus on, and how to leverage them properly to get applications to production quickly, as quick as possible, so we could actually deliver business value as quick as possible and with a high degree of confidence. Right, so no need to reinvent the wheel every time. And so we distilled all that knowledge into an operator, a Kubernetes operator, which is essentially a custom Kubernetes extension that encapsulates all of our best DevOps practices in code, so everything can be automated. So that is what's being installed right now. And the starting point for this was really to we started with the developer's experience. How can we design these operators so that teams are able to innovate fast, but also continue business as usual, for existing critical applications that need to be maintained in that new environment. So we can afford to retrain developer for months in order to be productive with containers. And then we started with that, and then we incorporated all the other elements that are sort of behind the scene, from a developer's perspective, like auto-scaling, monitoring, logging, which are, you don't necessarily have to know how to set these up to start building applications. And so we have, complete peace of mind, at least as soon as the first application lands in production. I'm going to finish get it set up. It's going to take just a few more seconds. Let's see. So this is a recorded video, and the reason for that is not for us to cheat and make it look easier than it is, just because some of these processes are very easy, like this installation, but it actually takes maybe a couple minutes to actually run through the installation process, and so I don't want to bore you with the details, and also in case the demo gods were not with us. So I'm going to jump a little bit forward and show you. So this is our operator that's actually in the Operator Hub catalog out of the box when we set up OpenShift. We did the dependencies installation, and now we're installing the actual proficient operator that's going to give us like some of these abstractions that we need as developers to really avoid having to learn a lot of stuff about Kubernetes. Let's see, let's keep this. So once it's installed, you're going to see on the right side, there's 3 type of objects or APIs that are now available through this operator. And so these are the extensions that I was talking about earlier. And they're like high-level objects that then are describe internal Kubernetes APIs. So the first one is the DevSecOps Manager. It's kind of like the top level object. When we create that object, it's going to set up a few default things that are going to be required across the board for all your applications, for all your projects, and there are going to be logging ability, monitoring, alerting, things that are used like build pipelines for CICD for Java applications or other type of applications. Anything that's really like common to all that all that type of work. So the way this works, let's go back a little bit. You're going to see in one of the parameter, so that's just a YAML file. That's how you describe these objects in Kubernetes, and then you just send it to the cluster like you would like a normal REST API. And in that YAML file, you're going to see there's a field that points to a Git repository. So at the core of all of that operator is really GitOps. And GitOps is, what the practice of storing the state of the cluster in code repository. All right, and so the idea is you never do anything on the cluster directly, like in an interactive mode. You actually put all your state configuration in a Git repository, and then the operator will sync those configurations with the cluster automatically. So here we're gonna start by creating what's called managed namespace. So this is gonna be a project in which OpenShift deploys application, and so that's typically either by big application or by project team. So we have a namespace here that's specified, and then all these other configurations is, another Git repository here where we're pointing to the Git repository that has the configuration for the applications in the namespace. The second one is where are we going to be storing our container images, and I'm going to create the project so that it doesn't complain. All right, and that's the name that I just showed you guys in the project file, in the YAML file. And so right now nothing is deployed, right? So we're gonna go into here, which is where we actually deployed our the main object for the operator. And then we're going to go into Argo CD. Argo CD is the tool that we use for the Git Ups to synchronize the Git repository with the Git repository with the cluster. I'm going to go and grab the admin password that's been generated automatically during the installation. And so that kind of gives you, you're going to see here, like this on the left is the main application. And then on the right side is the other namespace, so it's going a little bit fast. So that kind of shows you what's being right now, what is being deployed on the cluster. And so that managed namespace here is what we have in our Git repository, right? So it already picked up on it, right? So this is what's being actually synchronized, right, in Argo CD. All right, and then I mentioned the second Git repository is where we actually store our application configuration. And so when you want to deploy an application, really all you have to do with this operator is create a YAML file that is represent the Spring Boot app. Oh, it's a little bit fast. Yeah, Spring Boot app, which is an abstraction of a Java Spring Boot application in our tool. And again, that's just a YAML file. And so in that Git repository really is, just a quick description of what your application looks like, right? So I have a simple echo service here that's just a basic Java application, nothing special. And I'm going into my YAML file here, and I'm kind of pointing out where's the configuration for that application, which is this repository we're talking about. Where am I going to store the image for that application and like the name of the image, and then where the source code for my application is. Right, and so this registry here matches this one. This Git repository is where the application code is. So I was just showing earlier. And then some random, standard Kubernetes configuration. One of them is the Maven mirror in case you have like a Nexus or a Manufactory or something like that. What port the service is running on, and then some other pod configuration that you might not need to use. And then version information, well, I don't think we'll have time to get to that. But multi-version management is one of the things that we are enabling. So this is the Spring Boot application. It's like I said, it's out of the box. Spring Boot application is very standard. There's just a few things that we're adding in order to make it easier to integrate with Kubernetes. One of them is the Spring Boot actuator for the health checks, the probes. Some of the metrics of your application can be exposed through that. And so that's using the Prometheus module that is the default monitoring system in OpenShift. So you just need to include the dependency in your Spring Boot application, no code change required. That's kind of production ready out of the box. The second one is the Spring Cloud Kubernetes dependency for Spring Boot that's allowing us to load configurations from Kubernetes secrets and Kubernetes config map. So externalizing configuration for application according to 12-factor app best practices. This one here is to be able to log the application in JSON formats so that it can be parsed and analyzed properly. And then this final two are just for application tracing and APM, and that's going to tie into the open tracing Jaeger or Zipkin tools in OpenShift. So I already had like the application deployed in Git. So as soon as I created that main application, right, it picked up that I already had a namespace configured. So that's what's showing here. And if we go in there, we'll see that it also automatically picked up on the application, the echo service application that I have in my Git repository, right? So that is this configuration file here, and then this Spring Boot configuration as well, and then the V2 actually is not used at the moment, but it got synchronized as well, right? And so based on that, the operator picked it up, and then it synchronized all the CMO configurations. That's the Spring configuration, standard Spring configuration, easy to understand. And so it went and synchronized these things automatically. And so it created like a number of things for us: the deployment configuration, the service, which makes our web service available inside the Kubernetes with the host name through the internal DNS. And then it created also a route so that the service can be accessed through from the outside of the cluster. So like all these things happen automatically, and you can see one of the objects that was created, the deployment config, which manages like how the pods or the applications are to be deployed. And then you can see that the application has already been successfully deployed and is outputting logs already. And then the route that I was referring to, which points, gives you a URL that you can click, and this is the application deployed in the cluster, and that's working. Right, so you can see that from a developer perspective, really didn't have to interact with the cluster at all. They didn't have to do anything with like containers. All they really have to do is like point to the GitHub repository, create their YAML file, and just wait until the operator picked up on it and started synchronizing. Let's go through this quick. All right. So now we're going to see. So one of the things that happened when we created that first big object, right, the DevSecOps manager, and then the namespace is that it automatically will add a CICD pipeline for applications, for Java applications, and that's built on top of Red Hat pipelines, which is itself built on top of Tekton, which is a Kubernetes native CICD. So it's kind of an alternative to Jenkins, but they can work together. So that shows you kind of a basic pipeline right now where we get the code, we build using Java Builder here, and then it goes and update the staging, deployment, and update the production deployment automatically for us. And so the only thing we need to do is really specify in so the Quay.io, if you're not familiar, that's a repository for container images from Red Hat, and so that's kind of like a Docker Hub type deal. So when our images are built, they're pushed into this registry, right? And then that's what's referenced in the code here. Going a little bit too fast, sorry. That's what's being referenced here in the code. That thing is actually what I was showing you in Quay right now. So right now, this application that's running, because that's how I initialized it at the beginning, I'm going to show you really how simple it is to now update the application and see how it's going to automatically kick off the pipeline. Really, one thing that I have to do is go into my GitHub repository where my application code is, and create a webhook so that it automatically kickstarts the pipeline, the CICD, a commit is made to the code, right? And that URL is actually provided by the operator automatically when you set it up. So I'm going to do a little bit of the unspeakable act here of making a change to this application in the GitHub directly. Normally I would do it on my environment and then commit, but for the sake of speed, I'm doing it here. I made a quick change, and I'm going to go back into the webhook and then make sure that that code change was actually picked up. And yeah, so the webhook actually communicated with OpenShift automatically, and then you can see the CICD is starting. So that's the part that I kind of sped up because it's kind of like getting the code from the Git repository and loading all the Maven dependencies and then compiling the code. Nothing really interesting to see here, but like just to show you a little bit of like the UI that's available in OpenShift pipelines. It's kind of not dissimilar to Jenkins. And at the end of the build, after it generated all the Maven Marjari files essentially for my Spring application, it will also create the container image, right? That's going to be used to deploy into OpenShift. Let me give it a second here. This is just Maven noise, compiling the application, etc. So we're going to go back into the namespace where we deployed. While this is building, I just want to show you a little bit also of this thing, Grafana. I don't know if you're familiar with that's the visualization tool for metrics. And so if you remember earlier, one of the dependencies that I added was the Prometheus metrics module to Spring Boot. And so it's outputting like all these variables, all these metrics automatically. And then the operator has created a custom dashboards for it. So it's kind of show you out of the box, right? JVM metrics, some web server stats, very important stuff like request duration, so you can monitor the performance of your application, response time, etc. And then error codes, whether you're getting a lot of errors or not, and so that can be tied to then alerts and escalation for operation teams. So that's something that's available on OpenShift out of the box, right? They are using that kind of under the hood, but this is not really customizable because of the support. It would cause support difficulty for Red Hat potentially. So this is something that we make available for you guys to be able to create your own custom dashboard for operation centers and stuff like that. Right, so the image has been created. It's been pushed to Quay. You can see that 7E. There you go. So that's the new tag. That's the new version that's been created. And then the next stage actually went and updated our YAML configuration in GitHub. Right, that Spring Boot YAML that we were looking at earlier in GitHub. It automatically went and updated the image tag in the YAML file, right? So you can see the new tag in there, E70. That's what we just built. So that got pushed to GitHub, and now look at this commit number, and we go back to our Argo CD. Our operator is detected like the new commit. Right, so it detected that there's a new version of the Spring Boot YAML file You can see it's like blank. That means it got synced. And so if we go in there, we can see that the new image has already been deployed with the correct tag that we just saw in the registry. Right, so that's really the quick path for, you have an existing application, you quickly create a YAML file, it get deployed, and then if you want to make start making your bug fixes, you can do that right away, and you haven't really had to interact with the Kubernetes cluster at all so far, right? So the other thing that was automatically installed by the operator, very important for day 2 operations, is logging. And out of the box, OpenShift does logging aggregation, right? So that means it's going to pick up all your logs for your containers, and it uses Elasticsearch as a way to store and search through the logs. But again, like the Prometheus Grafana thing, you cannot really customize it because it is used by OpenShift internals, and if you start messing with it, it might break things and you might lose support. So we actually have our own Elasticsearch stack that we put up next to it, and then we use the OpenShift forwarding features so that some of the logs, right, the logs of the particular applications that we just deployed, are being forwarded to this separate Elasticsearch stack, and you're actually able to modify the configuration of this Elasticsearch index, right? And so if you're want to do custom reports, or you want to do custom processing of the logs, you can do that. And because it's JSON format, right, because we added the dependency to our Spring Boot application earlier, it's actually parsable, and you can analyze it, etc. Right. So yeah, so these are the logs. I'm going to try to generate a bit of logs to show you just how that works, right? So I'm going to generate a little bit of traffic. Right, so the application is already deployed. I'm going to go in there, and you're going to see. So this is in the console, right? For the one pod, you can see that the log will show that I did send a message. We're going to refresh here, and we're going to notice that the logs have been automatically forwarded to our custom log instance. Right. This is the traffic that we generated. All right. So let's go to, yeah. So a little bit of extra also for day 2 operation. That's very important. That's how to how to actually trace your application. So what's going on if you have multiple services running. You need to trace the different calls to your different applications, and be able to trace the call and see if there's any bottleneck, or if an exception occurs, you have to be able to trace it back to where it's coming from. And so that's the tracing aspect using open tracing. The integration has been automated, right, in our operator. And it's kind of showing you like all the details of what happened in that particular service call. And one of the things that is that we did automatically for you is connect the tracing with the logging. And so the trace ID here, if we're going back to our logging UI, we can actually search by trace ID, and that's going to show us all the logs that belong to that that belong to that trace. So when you have one application is not necessarily super useful, but when you have microservices that talk to each other, you're trying to figure out what exactly happened on all the services that are forming that process from end to end. You need to be able, you can look at that particular trace ID and you'll see all the traces related to the entire transaction from the UI all the way to the back end, potentially like some other enterprise backend services. So that's being done automatically. And I just generated an error trace, right? And you can see that that error has been picked up. So I'll show you some like basic error information again, some application tags, et cetera, and then we can go into Elasticsearch and again look at that particular trace, and that's where it becomes really useful because then when I put that trace ID, I can see if the particular exceptions tag trace that have been generated by the service that caused the error, right? And so you can look at like a number of fields that will give you a lot of insight on where your application might be failing. Let's skip over that real quick. All right, and yeah, I'm going to go into now. So we have our application deployed in like a staging environment at the moment. So we're going to see how using this operator, we can easily also take care of how to promote applications to a production cluster. Right, so instead of like creating a second cluster, I'm just going to simulate that by creating a second namespace that's going to act as essentially our prod, cluster. So here I'm creating I'm declaring a second namespace that I'm going to use as prod. I'm going to say, the repo URL is going to be the same, but I'm going to put that configuration in a different branch. Everything else is pretty much the same, right? Because we want to deploy the same application. So in the, let's create that project. There you go. And then I'm going to go into here and I'm going to commit that YAML file to my GitHub repo that stores all my cluster configurations. And then we're going to see that, if we go back into Argo CD, we're going to give it a second. You'll see that it's going to pick up on that change, almost immediately from GitHub. It's going to detect that new YAML file. And give it a second to sync up. There you go. So again, that's going to create, the CICD pipelines, like all those shared resources, as if in this case it's a second namespace, but it would be the same on a second cluster, or X number of clusters that you want to sync, essentially. Right. So you automatically created that fake prod application kind of tracker here. It synced it, detected that that I have a service that I want to deploy in there, and then it looks exactly like the other one. So so it's syncing all of that stuff. It's deploying my pods right now. We're gonna speed through and just check that it actually deployed on the second namespace. You can see the URL fake prod, right? And so now my application is essentially being promoted to production. So now they're in sync. So we're gonna go even a step further, and we're gonna say, okay, how now do we do? How do we stage a change have potentially the QA team run some tests, potentially UA team run some tests, and then what's the process to actually promote that change to production in a controlled manner where you need somebody to actually approve the change. So I'm going to go into my Spring Boot application here, and I'm going to make a quick change to the code. And so in the new version of the service, and it's going to append fake prod to the message that's returning. I'm just going to commit that code, and then so that's going to go through the CICD pipeline, build that code, build the image, push it into Quay, and then on my dev namespace, right, it's gonna pick up on the change, and then in a few seconds it should automatically start deploying. We're going to see the change for the application that the CICD, so it built that new version, it's synchronized, and then Argo CD is now going to automatically go in and update that thing. There you go. So it's updating right now. You can see that the image has already been deployed to the image repository, and then we can see on the right side our new pods are being deployed. There you go. Okay, and so as deploying, if we go to our back to our cluster and we go into the deployment, we're going to see that it's actually doing a rolling deployment, right? So it's replacing the old pods with the new pods. And here I've configured to do it, 33% of the pod at a time. So there's no interruption of service. And that's configured automatically again through the operator. And when it's completely replaced, we're going to be able to go back to the browser and see, okay, so this is done. If we go back to the dev namespace, right, it's the staging namespace. So this is on the prod, right? And then we can see on the dev, it still says test, right? So now we have a dev version that's different from prod, right? So at the time when we're ready to promote the change, you're gonna see in your GitHub for the namespace configuration, you're gonna see that the CICD automatically created what's called merge request, right? So it's staging that change to the application, and it shows you what is currently in production, and what you want it to be, right? So what's currently on dev, and then it's prompting you if you want to merge that change and allow that application to be deployed to prod. And so you use a very the practice that's very, very standard in development teams. They know how to use that. To confirm that merge, and now that's going to cause Argo CD to detect the change in the production cluster, and it's going to start syncing as well. There you go. So you can see that it's syncing here at the top. And that just takes really just a few seconds. Here we go, and you can see the commit message that is syncing right now, merge pull request number 9. So that's the promotion request that we did. And you can see that the pods are being updated, right? The deployment is being updated automatically on production. So if we go back to our fake prod namespace, we'll see the same thing that happened earlier in the dev environment, where it's scaling those pods and syncing, right, that container image tag. And so if we now go to prod and we refresh, once the pods are already deployed, here we go. If we refresh, you're going to see that now it's returning the new version of the service that we just promoted. Okay, so that's kind of the basic migration path. And again, I would point out that from a developer's perspective, it really didn't require any prior knowledge of Kubernetes or containers for that matter. You can pretty much take your Spring Boot application as is, just create a YAML file that points to where the code is, and then it will do all of the things automatically for you. And then one more thing that I wanted to show you that is tied to a little bit of the monitoring aspect that I was talking about earlier with Grafana, with some of the metrics that we're actually collecting is, the operator deploys a few alerts by default, just so that there's a basic basic quality check on the applications that are deployed in production. Response time, want to make sure the service is not slowing down or getting unusual amount of errors. So this is in addition to the OpenShift monitoring system, which monitors the containers themselves, but really don't have any knowledge of the internal of your applications, right? Because that it's made to run only Java, but Node.js, .NET, whatever the case may be. And so these particular metrics are specific to Spring Boot, and because we know it's Spring Boot, then our operator is able to do some of these automatic kind of assumptions, and then you can tie those alerts to your escalation tools through the OpenShift built-in alert manager, and so you can tie to PagerDuty or Slack, or send emails, or whatever your process might be at the moment. Yep. So this is the demo. So I mean, this is a small part of what the operator can do. There's a lot of other things that we didn't have time to touch on, like blue-green deployments, canary deployments, security, traffic management, service mesh integration, all this kind of stuff. But also, it's not only a tool, and it will help you get started really, really quickly. And if you're doing it with ROSA, then really your infrastructure needs are taken care of, your DevOps needs are taken care of, and you can just focus on application development and migrating your existing application. So that's going to be a very efficient tool for that. But also because we know that it's not a one-size-fits-all, it could be a starting point for you where it's really a process, right? And this operator can be modified and tweaked to fit your needs more specifically. And one of the benefits of doing it through the operator is that it will retroactively apply to all your existing applications that are already deployed using this this operator. And so if you have a new policy coming in for, I don't know, securing your web services with OAuth, that's something you can do at the operator level. And then you're making that operator change automatically apply to all your existing applications. So it's really, about governance as well, as, fostering a kind of a culture of collaboration between developers, and, doing that through a proper, proper channel using Git and pull requests, etc. Yeah, Caitlin, I'm gonna. Yeah.
We actually have a question. What is the value add that you provide when compared to Red Hat professional services or other ROSA vendors? Does Perficient have any tools to make migrations quicker or flawless?
Yeah, this particular accelerator, that's really the value add, because that's I don't have time to show, but if you look at the operator code, this thousands of lines. There's a lot of configuration files. There's a lot of little tweaks, configuration properties that we've learned to tune over time, and particularly because of our knowledge of Spring Boot application development and our delivery experience in a lot of different environments. So the Red Hat professional services will help you get started with the cluster. They will give you pointers, some best practices, etc. This is a lot more tactical, right? Like when you need to move to container tomorrow and you need to start deploying your application tomorrow. You already have your code in Git, you point to that, and then it's going to deploy it, and you're able to have this application in production in your cluster really, really quickly. And then as you're figuring out, how you're going to be using the cluster to better fit like the specific of your organization, then at least you have this thing as a starting point. And the approach, using operator to manage all these things is, as far as I know, it's very unique to Perficient. And other vendors will, not have that approach. They will build a lot of like custom solutions that are not necessarily going to scale, or it doesn't come with the process that's associated with that operator. So that's the big value add, right? And Perficient then coming in and teaching you how to own that process and tweak it. And our knowledge of legacy application, things like running on WebSphere, etc., the common pitfall that we have identified, and help you use some of the Red Hat tools like the migration toolkit to identify those problems and make sure that there's going to be a smooth transition.
Okay.
Hi, Caitlin.
Yep. Did you want to talk about our two offerings?
Yeah. So get back. So I mean, the first way, the easiest way to start, if you already have an OpenShift cluster or you're trying out ROSA, you can stand up a cluster really quickly. Go into the operator hub and you'll see the operator in there. The documentation is a little bit sparse. It needs a little bit of work. But I think the best way to really get started is these two offers that we have. One is the Ignite program. So that's a program in partnership with Red Hat, where some funding is coming from Red Hat and Intel, some funding is coming from Proficient, and we're investing in your organization to help you kind of assess your current state and like the fastest migration path, where can come in and help you set up the ROSA cluster, set up the basics, and then kind of deploy POC, do a little bit of a workshop around that, and in like a control environment, so you can see a little bit more what we just saw right in this demo, but like expand it to really include your organization specific processes and tools, etc. And so yeah, check with us if you can qualify for that. We come in and do an assessment and like do all these workshops, and then if you're interested in a little bit longer term, we also have an accelerator program that's a 12 weeks program that is front-end with the Ignite program in general, where we actually customize the accelerator for you guys. If you have some tools that you already invested in, like Jenkins, and you don't want to use TechFont, for example, so we can go and tweak that, and then we actually take a few apps and migrate them, and take them all the way to production, and make sure the process is established where you can really then hit the ground running and start moving applications in bulk after that. So again, 12 weeks program. A few engineers with different profiles, from DevOps to app dev, and then like really go more in depth in the migration process.
All right, thanks, Matt. The last thing we want to share with everyone today is we do have a few additional resources in the form of blogs on our website. Proficient is a launch partner for ROSA, so we have a blog post that talks a little bit more about what that means, and then we also have a blog post kind of walking through the accelerator that Matt just shared. Our resources as far as who to reach out to if you're interested, our two alliance managers, Matt Kuntz and Emma Wexler, will be more than happy to help you out there. And again, this recording will be available in the next few days, and you'll receive an email with the link to the on-demand version. Thank you so much for joining, and we'll see you next time.